Hi there, well I'd like to thank everybody for the help and support and advice provided since my last video. I've received some fantastic tips, and on a couple of occasions Mr C suggested I ought to get a better bandsaw blade, and Alex also suggested I ought to get one as well, so I both recommend a 10/14 one, bi-metal one, and Alex suggested using a company called Mr Bandsaw, so I sent off for 3 of these. He advertises on eBay. And they're made in the UK. Just put one on the bandsaw, fantastic. So I would highly recommend those. So thanks to both of those guys for the suggestion. Also, Peter sent me various articles through on email on how to make piston rings. So I'll be looking at those in some detail in the future. Others suggested I ought to have used a roughing end mill when I was machining some of these sides. At the time I didn't have one, but I've got some now. Simon Burt sent me through a new ignition system for this new engine, and he's also made a spark plug. Unbelievable. So that'll be going in the new engine. And in this video I'm going to be machining the cylinder sleeve and the piston for this odds and ends engine. Now, a while back when I was machining the cylinder sleeve for the Farm Boy, James Chaff suggested, rather than going through all that hassle of between centre boring and stuff, to use something called CDS, which is cold drawn seamless steel. And at the time I thought I'd buy some just out of curiosity, and I got a piece. And does look really good on the inside, really consistent internal diameter, but unfortunately it's a bit on the large side. So what I've been waiting for is another piece, so that's just arrived today. So what I'll be doing in this video, I'll be machining this down and explaining why I've gone for this particular internal diameter. Okay, so Earl has already machined his cylinder sleeve and piston. He's very kindly sent me over his machining notes, which I'll read in conjunction with the book. And Earl's using something called DOM, which is drawn over mandrel, which is similar to CDS, but I think the manufacturing process is slightly different. But both give a really nice finish on the inside. Now, the size of this, the outside diameter is 31.75 millimeters, which is 1.25 of an inch, and the wall thickness is 3.25 millimeters, which is 0.128 of an inch, and the internal diameter is therefore 25.25 millimeters, which is 0.994 of an inch. Now, as a bit of an insurance policy, I managed to find some Viton rings which are 0.996 of an inch, so they're 2 thou over this internal diameter. And it's a bit of an insurance policy for me, is this, because I'm going to have a go at machining the piston rings from cast iron, but if that's a total disaster, I want to be able to revert back to an alternative, which will be to use Viton rings. So I reckon that once I've brought this down to sort of size and done a bit of honing and a bit of lapping, it's not going to be far off 0.996 of an inch. So fingers crossed, if me piston rings don't work out, I'll be able to revert to a Viton ring. So I've got it in this 4-jaw chuck, and that's pretty much as close as I can get it. So what I need to do now is to face this off, this end, put a little chamfer on, which will help when I insert the piston with the piston rings, and bring this outside diameter down by a few thou just to tidy it up. Oh, didn't quite get it. I'll have to give it another pass. Looks okay. I've just set the compound slide to 5 degrees, and the idea is I'm just going to take a few thou off the inside of the bore. Okay, so I've just reversed it in the 4-jaw chuck, and that looks pretty good. So what I'll do now is I'll just face this end off here to length, and then I'll take a few thou off here to match this outside diameter here. And having done that, I'll put a very slight taper on here, so that'll help me when I press it into the cylinder block. But I'll do all that off camera. Okay, so I've just used this internal measuring gauge to check the internal diameter, and using the micrometer it measures 0.9946 of an inch. Okay, so what I've done here is I've just turned the end of this aluminium down just so I can get a nice fit and double check my measurements, and that just fits, just a little bit of play, not a lot. And measuring that comes in at 0.994 of an inch. So it's 6/10 of a thou less than this, which makes sense. Now I'm going to make a lap out of this, and a lap needs to be 2 thou smaller than the internal dimension of that. So I'm going to adjust the cross slide by another thou, so in other words 2 thou. And just take that off. Okay, so I've got this 1000 grit lapping paste. Give it a try. Well, I can't say I'm happy with the results so far. You can see some very fine lines inside. I think the problem is my lapping paste is only 1000 grit, so I think I need something a little bit more coarser. So I'm going to send off for some 500. And I've just checked the internal diameter, and after honing and lapping, it's taken 1/10 of a thou off. So it's now measuring 0.9947 throughout its length, which is pretty good. So I'll send off for some more lapping paste, and in the meantime it doesn't stop me from making the piston, because when I lap it again I'm not going to take more than 2/10 of the thou off, to be honest. So I'm going to make the piston out of this little piece of aluminium bar, and I've only just realised how sort of fine these piston rings are going to be. So having read various articles and sought advice from Earl, what you need to do is measure the inside dimension of the cylinder. Now I reckon it's at the moment 0.9947 front and rear. So if you call that 0.995, the advice is that the width and depth of the piston ring should be between a 25th and a 30th of the cylinder internal diameter. So that comes to 0.0398 of an inch to 0.033 of an inch. Now I've just made this tool here to make the groove. I've just measured the end here, and I reckon it will make a groove of 0.0365 of an inch. Now the groove needs to be 0.0005 of an inch wider than the piston ring. So that means that the width of the piston ring needs to be 0.0360, and the thickness should also be of the piston ring 0.0360. However, the groove depth needs to be 4 thou bigger than the actual sort of thickness. So the depth needs to go to 40 thou. So that's the plan, but these rings are going to be minute. Okay, so I've just spaced this off and just taken a few thou off this end here, and that measures 0.999 of an inch. Now the piston needs to be 2 thou less than the internal cylinder bore, which is 0.995, so the piston needs to be 0.993, so there's 6 thou to come off that. So what I'll do is I'll take a thou off at a time and just double check putting the cylinder up against it, and that'll give me a good idea as to how close I am, and obviously I'll keep on miking it as well at the same time. That's a very close fit, is that? So I reckon another 2 thou to come off the overall diameter and we will be there. Duclos. So I've got this little grooving tool in here now, and I've moved it from the top 3/32 of an inch. So now I need to go to a depth of 40 thou. So I need to move it down. I need to create a space of what was it again, 0.09375 of an inch, and then cut another groove exactly the same, 40 thou deep. I'll do that bit off camera. So now there's a requirement to open this end up, initially 7/16 in diameter to a depth of 1 1/4 inches, but I'm going to start off with this 6mm drill bit. So now I need to open up this bottom section to 13/16. Okay, so now I need to drill this hole for the wrist pin. I'm just checking that the piston is parallel with the bed. It's spot on. So what I'll do is put an edge finder on here and find the centre position. Then I'll move from this position here 5/8 of an inch in, and then I can drill and ream the hole for the wrist pin. Okay, so now what I need to do is to drill and tap the holes for the set screws for the wrist pin, and also bore out some of this aluminium for the little end to fit in there. So the way I've set it up is I've just put this brass rod in here just to make sure. I've just eyeballed it against the edge of the table to make sure you know, it's parallel, and it is. And I've used this edge finder to find the edges up both on the X and Y axis, so I'm now centered in the middle. So I just need to drill and tap and do a bit of boring, but I'll do all that off camera. Well, the 500 grit lapping paste has arrived, so we'll give it a try. I think this will take a while. So Earl advises me there's something called a drop-down test for pistons and cylinders. The idea is if you put the piston in, it should just drop down under its own sort of weight. Try again. Oops. Yay! So if we push it back up again and seal the top, it should stay there, which it does. Take my hand away. Hey! So I think it's just passed the drop down test. Well, they seem to have worked out okay. I'm really happy with the result. The fit seems great. And I never realised how thin these piston rings are going to be. And that's something I'm going to be having a go at in the next video. But anyway, I hope you found the video of interest, and I hope to see you later.